Hi, welcome to 一乐一学 Charisma. In this video, we will go through the formulas that are required in Section 1, General Physics. Period means that time required to complete one oscillation. From this definition, we can develop up one formula. Average time period of an oscillation will be equal to total time divided by number of oscillation. The unit for the time is second, then average time period here, the unit will be second also. The next formula will be S equal to capital D divided by T. Capital D is mean that distance with the unit meter. The T here is the time with the unit is second. The S here is the speed with the unit of meter per second. Average speed will be equal to total distance traveled divided by total time taken. With the unit for the total distance traveled is meter, the unit for the total time taken is second. So the average speed, right, the unit will be meter per second. The next one is the velocity. The velocity, right, the formula is V equal to S divided by T. In here, right, the S is the displacement with the unit meter, and then the T here, right, is time. The unit is second. V is the velocity with the unit meter per second. The next one is the acceleration. Formula of the acceleration is A equal to V minus U divided by time. V is final velocity or final speed with the unit meter per second. U, right, is initial velocity or sometimes also called as initial speed. Unit is meter per second. T is time taken. Unit is second. A is acceleration with unit meter per second square. For the motion graph, we have the two types of motion graph. The first one is distance time graph, and the other one is speed time graph. For the distance time graph, distance with unit meter, time with unit second, gradient will be equivalent to speed. For the speed time graph, if your speed is meter per second, time second, gradient will be equivalent to acceleration with unit meter per second square. Area will be equivalent to distance with unit meter. Weight W equal to mg. M is mass with unit kg. G is gravitational force, gravitational field strength. That is equivalent to 10 Newton per kg. W here is weight. The unit for the weight is Newton. Density will be rho equal to m over v. M is mass, unit for the mass is kg. V is volume. Unit is meter cube. Rho is density with unit kg per meter cube. From the Hooke's law, we have the one formula F equal to Kx. K is mean spring constant, or sometimes also called as force constant, with unit Newton per meter. X here is extension or compression with unit meter. Then the capital F here is applied force or root with unit Newton. For the Newton's second law, we have the one formula here, F equal to ma. M is mean mass with unit kg. A is acceleration with unit meter per second square. F here, you must take care about the F here, is resultant force with unit Newton. From the extension root graph, extension root graph gradient will be equivalent to 1 over spring constant. For the root extension graph, root extension gradient will be equivalent to spring constant with the unit Newton per meter. Moment will be equal to F times D. F is mean the force with the unit Newton. D is perpendicular distance from period, or sometimes we also can write as perpendicular distance from turning point. Unit is meter. Moment is moment, but sometimes also can call as turning effect with the unit Newton meter. Principal moment is mean sum of anti-clockwise moment will be equal to sum of clockwise moment. F1 D1 equal to F2 D2. A system in equilibrium, they have the two conditions for the system in equilibrium situation. The first one is no resultant force. The second condition here is no resultant turning effect. Okay, let's see the next one is for the momentum impulse. So for the momentum, P equal to mv. M is mass, kg. V is velocity, meter per second. The next one is P, is mean momentum, kg, meter per second. Impulse is equal to change in momentum. That is mean by final momentum minus initial momentum. with the formula mv minus mu. M is mass with unit kg. V is final velocity with unit meter per second. U is initial velocity with unit meter per second. Impulse also have the other one formula that is equal to Ft. F equal to force with the unit Newton. T is time with the unit second. Impulse have two units. One of the unit is kg meter per second and the other ones will be Newton per second. From this conservation of momentum, it means sum of momentum before collision will be equal to sum of momentum after collision. For the elastic collision, we will use this formula m1u1 plus m2u2 equal to m1v1 plus m2v2. For the case in elastic collision, m1u1 plus m2u2 equal to m1 plus m2 bracket times v. For the explosion, 0 will be equal to m1 v1 plus m2 v2. From the formula, m1 is mean mass of car 1 with the unit kg. m2 is mass of car 2 with the unit kg. u1 is initial velocity of car 1 meter per second. u2 is initial velocity of car 2 meter per second. Then the v1 is final velocity of car 1 meter per second. v2 is final velocity of car 2 meter per second. The last one is v. v is common velocity of car 1 and 2 together with the unit meter per second. The next one is kinetic energy. Ke equal to half mv squared. M is mass, kg. V is velocity, meter per second. Ke is kinetic energy with unit J, joules. Gravitational potential energy, GPE, equal to mg delta H. M is mass, unit is kg. G is gravitational acceleration with 10 meter per second square. Delta H is change in height with unit meter. GPE stand for gravitational potential energy, joules. We have the two formula to find out efficiency. Efficiency equal to useful energy output divided by total energy input times 100%. Unit for the energy output is joule. Unit for the energy input is joule. Efficiency is %. The next formula for the efficiency is useful power output divided by total power input times 100%. Unit for the power output is watts, W. Power input, watt. Efficiency, %. Work done will be equivalent to energy transfer. W equal to F times D. F is force with the unit Newton. D is distance moved. And then this one must have same direction with force. Unit is meter. W is work done with unit joules. Power P equal to delta E over T or W over T. Delta E is energy transfer. Unit is joule. W is work done. Unit is joule. T is time taken. Unit is second. P is power with the unit watts. P equal to F divided by A. F is force, Newton. A is area, unit is meter square. P is pressure, unit is Newton per meter square. But normally we will be write as Pascal. PL equal to H rho G. H is depth of liquid. Unit is meter. Rho is density. Unit is kg per meter cube. G is gravitational field strength. Newton per kg. PL is liquid pressure with the unit Pascal. Okay, so that is finish our session 1, all the formulas.